Hello and welcome to this guided demo to the Oracle DBaas Cloud Service Architecture. This demo shows you at a high level the various Oracle DBaas Cloud single instance service components and their interactions. From now on, we will refer to this service as DBaas Cloud Service or DBCS. We do not get into the details of how you can get an Oracle Cloud account, and we suppose you already done this phase. As an identity domain administrator or a service administrator, your main entry point to manage your services is what we call the My Services web console or dashboard. From that web page, you can get an overall information about all services running in your identity domain. From the My Services page, you can open what is called the Oracle DBaas Cloud Service Console, another web page allowing you to manage your DBCS environment. Note, the My Services page computes DBaas metrics periodically. From the DBaas console, you can create, delete, start, stop, restart, patch, backup, recover, and add new SSH public keys or scale up and down what are called DBCS instances or DBaas deployments, a combination of resources used to give you access to an Oracle database. To be able to get to both the My Services and DBaas consoles, you need certain privileges granted to your database cloud service account through roles. For Database as a Service, one role exists and is automatically granted to the identity domain administrators and is called DBaas, Database Administrators. With this role, you can manage all instances in your domain. One of the main components of a DBCS instance is a virtual machine called DB1 and created with a certain compute power that we call a shape, a combination of a number of CPUs and RAM. Within this VM, you find an Oracle database already installed and created. This could be an 11G R2 or 12C R1 database, depending on how you defined the creation of your service instance from the DBaas console. By default, this database is created using AL32 UTF-8 character set, but you can select a different one, like you can select the time zone different from the default UTC. Also by default, every non-system tabular spaces are encrypting using TDE technology. And hybrid columnar compression is also available. Of course, you also find within the VM all local tools you are familiar with to administer your database. They are the same as the one you find on your on-premises installations like SQL Plus, Recovery Manager, EM Express. In addition, you find Oracle REST Data Service, or RDS, which makes it easy to develop modern REST interfaces to administer your database deployment, as well as the Oracle Application Express. Something you will not find on your on-premises installations are the cloud tooling for easier patching, backup, recover, and monitoring of your Oracle database. If you want, you can back up your database to cloud using the DBaas Backup Cloud service. In terms of pre-created users, you will find Oracle and OPC, for which you have access. These two users do not have passwords, as we are using SSH keys to connect to these users. OPC, or Oracle Public Cloud User, is a user with sudo privilege to run root commands. The Oracle user is the one used to install the Oracle software. Very important are the accessible network ports by which you can access your VM through the network. By default, only SSH port 22 is open for communication, which allows you to create tunnels for the other ports while they are blocked. As we will see, You have the possibility to unblock them if you want. Last but not least, you will get a file system where software and data are staged. You have 4 GB of swap space, 16 GB for the root, where /u01 software, /u02 your database files, /u03 your database backup files, and /u04 your database redo log files. All this is configured automatically for you. When creating a database deployment, you choose the amount of usable data storage you want for your database in gigabytes increments, up to a maximum of 2 terabytes. After you create a database deployment, you can add more data storage as needed. By adding more storage, you can create a database of up to 4.6 terabytes with local backups, or up to 12 terabytes without local backups. So, to create such a VM, all you need to do is to go to your database console and answer a few questions like the shape of your VM, size of your database storage, where to store backups locally, on storage cloud, both, or no backup at all. You need to give your service instance a name, an SSH public key used in conjunction with corresponding private key to securely connect to your VM once created through SSH communication. You specify also the total size for your file system, a unique password for all key database users and encryption password, a database name, and optionally a pluggable database name. You also have the possibility to select your time zone, character sets, use rack, data guard, or Gordon gate for replication. You also have the possibility to include a PDB dedicated to demo new features. At the time you create your database deployment, you need to specify an SSH public key which will be used in conjunction with a corresponding private key to allow VM access. By default, this public key is also called aura_user. Another one, aura_tools, is also created to allow your My Services console to securely communicate with your VM to gather various utilization statistics and metrics for your database and compute resources. If there is a need, you can add new public key for OPC and Oracle user to access your VM. This can be done directly from the database console. One important operation you can do directly from the database console is scaling your VM shape if you want to add more CPUs and memory to your database service. This operation will temporarily stop your service before the VM is recreated without loss of any of your data. The second scaling operation you can do from the database console is scaling your storage if you need more space for your database, for your backups, or anything else. All this done by a simple click. Another important operation that is automated from the database console is database patching. You also have the possibility to access directly from your database console the EM Express console as well as Apex console and database monitor. As for cloud tooling, you can see a list of tools that you can use to help you manage your database like DBaas CLI for patching, DataGuard, and recovering, MREC for last option recovery of your database, CleanDB logs for purging log files, Backup API for backups. Cron tab is used to automate backup creation and log purging. For backup and recovery, these tools are based on Recovery Manager with a simple syntax for basic operations. You also find a new web interface for monitoring your database and VM called DBaas Monitor. Regarding backup and recovery operation, you can create a backup or recover your database directly from the database console. If you choose to backup to your local VM, backups are automatically generated for your database files, database configuration files, as well as important OS configuration files. They are stored in /u03 using an incremental policy you can change. The retention period is 7 days by default on your local storage. In addition to block storage provided by the compute block storage layer, Oracle also provides a longer-term type of storage capability that can be managed independently of your database and called Storage Cloud Service. You interfere with Storage Cloud Service mainly from your browser using REST APIs by managing what are called containers. If you configured your database backup to also use Storage Cloud Service, then you must have created a new container before you can create your database as a service instance. This container will then be used automatically by your backup jobs to create object storage inside your container to store your database backups up to 30 days. Note that all generated backups are encrypted on both local and cloud storage. The special SBT library, libopc.so, is automatically used and configured for RMAN access to cloud storage through cloud tooling. You can also use a REST client tool to access ORDS to manage your database deployment using REST APIs. Looking in more details, your database as a service instance is comprised of a VM allocated from the compute infrastructure and an underlying block storage from where its file system is created. This additional resource is part of what is called compute block storage. The goal of the compute block storage layer is to allocate volumes that can be attached to your VM. A maximum of 10 volumes can be attached to a single VM, and by default, when you create your database as a service instance, 5 volumes are created. Boot, which is 20 gig, bits 30 gig, data, depending on the size you specified for your data, FRA, which is by default 1.7 times the data size if you are using backups, and redo, which is 10 gigabyte. These volumes are automatically attached to your VM and then formatted and mounted appropriately. When scaling storage from your database console, you can add new volumes that will be mounted in new directories, or you can extend your data and FRA storage by adding new volumes to /u02 or /u03. For some of the compute resources, like volumes and network controls, you can manage them directly from another console called the compute console. You can access this console as long as you have enough privileges, like the compute operations role. From the compute console, you can add volumes you will mount to your file system after creation. This is considered as temporary need as the volume is not automatically attached to your file system. For network controls, you can manage security rules that controls port access to your VM by other computers on the internet. As shown on the diagram, a number of security rules are predefined to control access to specific ports used by various Oracle software like EM-Express, Database Listener, Database Control, or important protocol like HTTP, HTTPS, and SSH. By default, all those predefined security roles are disabled except the SSH one, allowing any computer to communicate through SSH. you can define security IP list to group a set of computers outside the Oracle Public Cloud used in your security rules. Security lists are groups of Oracle Public Cloud VMs between which communication is allowed or not. With these three entities, you can construct efficient firewalls between your service VMs and the outside world. When you create a security rule, you can specify a security list or security IP list as the source and a security list as a destination in that security rule. You also specify the security application, basically your protocol, and you enable it or not. From the DBaas console, you can manage security rules, also called access rules. From your compute console, you can manage all network controls. From the DBaas console, you can create storage snapshots, which you can then use to create new DBaas deployments called linked clones. When you create a storage snapshot, the database deployment is put into maintenance status and a snapshot of all the storage volumes for the deployment is taken to your storage cloud container. Using the copy on write technology that Oracle Compute Cloud Service supports for storage volume snapshots, the file data on the linked clone deployment can change without changing the snapshot itself. Thus, you can create several linked clones from the same snapshot to use for application testing or branched application development work. You can create a DBCS deployment from a snapshot you have taken of another database deployment in the same identity domain. The created deployment is called a linked clone because its storage is linked to a snapshot storage. As you step through the creation wizard, you will note that several options are not selectable. For example, service level, software release, and software edition. Such options are not selectable because their values are determined from the snapshot upon which the linked clone is based. Other options are required, like a new service name and an SSH public key. You can change the other selectable options from their defaults if you want. For example, shape and backup destination. From time to time, you have the possibility to update your cloud tooling to take advantage of the latest functionalities. This operation is as simple as updating the DBaas tools.rpm file you can download to your VM from a special storage site using wget command. The last thing I'd like to discuss about this DBCS architecture diagram is the possibility you have to install the Oracle-DBCS-CLI utility directly on your Linux on-premises servers. You can download this utility from OTN and you can install it by unzipping it. This utility allows you to connect to Oracle Cloud and perform a variety of lifecycle and administration operations on your DBCS instances. In addition, you have the possibility to back up your on-premises database to Oracle Database Backup Cloud Service. To do that, you first need to install the Oracle Database Cloud Backup module. You'll download the opcinstaller.zip module from OTN and install it on your database server. Thanks for watching.